Lesson 9.5 is going to have us factor polynomials that are in the form x squared plus bx plus 1. Before we factored out common monomial factors, we looked to see what was the greatest common factor of each term. But now we have a specific polynomial that we're going to factor, and in fact they're going to be the trinomials x squared plus bx plus c. The leading coefficient of this is always going to be a 1 because it's a 1x squared plus bx plus c. B and c are real numbers. And this is kind of cool what ends up happening on how you factor these. So first let's look back at lesson 9.2. In 9.2, if we had, for example, the binomial x plus 3 times x plus 4, we could FOIL. X times x is x squared. X times 4 is 4x. X times 3 is 3x. So essentially, if they're in this form where both of these linear factors have a coefficient of 1, I could have just said 3 plus 4 and then times the x. And then 3 times 4 for the last term is 12. So x squared plus 7x plus 12. So what we're going to do now is reverse the process to actually factor. So when we look at this algebraically, we have x squared plus a bx plus a c. It's going to always factor into x times x because x times x will always give me x squared. And then we're going to say plus p plus q. Q and p are just real numbers, but p plus q has to equal the b coefficient, and p times q has to equal the c coefficient. So if we look down here at x squared plus 5x plus 6, it factors into x plus 3 times x plus 2 because 3 plus 2 is 5, the b coefficient, and 3 times 2 is 6, which is the c. C is not a coefficient. I probably said that before, but I meant the constant. So let's go ahead and work excuse me, on a couple of these. So when I have x squared plus 3x plus 2, I know automatically that it's going to be x and x. Well, I'm given very limited choices for factors of 2 because I want these to be integers. So I know it's going to be 2 times 1 or 1 times 2. It doesn't matter which one you put in either slot right now. Eventually it will matter. So here they're both separated with an addition sign, because I know that 2 plus 1 equals 3 and 2 times 1 equals the 2. So it checks. Plus you could always FOIL them back and see that it does equal x squared plus 3x plus 2. So on this one, I know I'm going to have a t and a t. And I know right now, since everything is addition, I'm going to have plus and plus. But my factors of 14, I look at the factors of 14, I can choose from 1 and 14 or 2 and 7. Well, the 2 and the 7 are going to add to 9, so I'm going to use 2 and 7. It doesn't matter if you do, again, 7 and 2 or 2 and 7. You're going to get the same exact answer. Okay, let's try another one. So this is what happens when b and c are both positive. B is positive, C is positive. So everything in here is addition. But in some cases, B is going to be negative and C is going to be positive. We're going to approach it the same way. I still know it's going to be x and x. And I'm still looking at factors of 3. And I only have a 1 and a 3 for my factors of 3, so I'm going to put a 1 and a 3. I do what I call the smiley face method. I sort of build a little smiley face. I know that my inside terms are going to be 1x, and I know that my outside terms are going to be a 3x. I need a negative 4x here. So these both have to be negative, and to make them both negative, I just put subtract, subtract. Because here, negative 1 plus negative 3 is negative 4, and negative 1 times negative 3 is positive 3. Let's try this one over here. So I'm going to have a t and a t. And factors of 12, I can go 1 and 12, 2 and 6, 3, and 4. The only ones of these that are going to end up giving me an 8, possibly, are the 2 and the 6. The 2 and the 6. So I'll go 2 and 6, and I know it's going to be a negative and a negative because I have to get a negative 2t and a negative 6t to give me the negative 8t. And negative 2 times negative 6 is positive 12. So if b is negative and c is positive, it's always going to be in the form x minus p, you could say, and x, oops, that's not an x minus q. So the p and the q are going to end up both being negative. And then the last scenario we're going to have is if b is positive and c is negative. So we have a positive b and a negative c. So here I know I need an m and an m. I need factors of 20. So I like to list them off. It's 1 and 20, 2 and 10, 4 and 5. The only factors here that differ by 1 are the 4 and the 5. So I'll put in 4 and 5. And this gives me a 4m and a 5m. I need a positive 1m, so this has to be positive. So I need a negative 4m. I just follow my parentheses, like my nose and my mouth. The nose part is the first set of parentheses, so this has to be a negative and this has to be a positive, and you can check it. Negative 4 plus 5 is 1, so 1m, and negative 4 times 5 is negative 20. We're getting a lot of delayed action here because for some reason my MimioPad is acting up right now, so sorry about that. Okay, so now if we look at this one, I know I'm going to have a w times a w, and my factors of 16, I know it's a negative 16, but I'm still just going to look at 16, are 1 and 16, 2 and 8, and 4 and 4. The only ones that differ by a 6 are the 2 and the 8. So I'll put a 2 and an 8. I need a positive 6, so let's check this. I have a 2w and an 8w. For that to be positive, the 8 has to be positive 8w and the 2 has to be negative. So negative, positive. And it does work. Negative 2 plus 8 is positive 6. Negative 2 times 8 is negative 16. And then the last type of problem you're going to get has more than one variable in it, but you're going to do it the same way. We have x squared plus 9xy plus 14y squared. The only thing that tells me is that I need to have an x and an x for x squared, and I need a y and a y to get the y squared. Now I'm just simply going to look at the 9 and the 14. So if I look at factors of 14, and I know some of you can do this in your head, and that's great. You don't have to always list out these factors. This is just my way of showing you how you can do it if you're not sure what to list out for the factors. The only ones that differ by a 9 are the 7 and the 2, and I've got a positive b and a positive c, so I know that these both have to be positive. So plus 2y plus 7y. And I can check it again. 2 plus 7 is 9. 2 times 7 is 14. And again, if you were to FOIL this back out, you would go ahead and get the x squared plus 9xy plus 14y squared. That is it as far as notes. I will go ahead and post the assignment in case you want to get started on it. This is going to be lesson 9.5, part 1, page 586 to 589. Problem number 1 and 2. 3 to 17 odd. 18, 19. Then we skip to 47, so 47 to 55. This is where you do the factoring and where you have more than one variable. 66 to 72 even. You will have class time to work on this tomorrow after we're done checking 9.4. But again, if you want to get it started tonight, that is up to you.